Lesson 26, Trinomial Factoring and Overlapping Right Triangles. Let's factor this quadratic x squared minus 7 minus 6x. The first thing we need to do is rewrite this in descending powers of x. Okay, so it's going to be x squared minus 6x minus 7. So to factor a quadratic, we're going to have the form parentheses times parentheses. Okay, all right, how we get the first term is the product of the first two terms. Okay, the first term in each group of parentheses. The only way to get x squared is x times x. So that we know. All right, let's analyze the rest of this. We need a product of negative 7 and a sum of negative 6. Okay, negative 7 product. All right, that means we're multiplying. How do we multiply and get a negative? Well, we know we have to have one positive times one negative. So we can put a plus and a minus in the parentheses. And all right, we need factors of 7. Right, so factors of 7, I like to do this. I like to do an x here. I need product of negative 7 and a sum of negative 6. So I put the product down here on the top and the sum on the bottom. Okay, all right, so what's the only way to multiply two numbers and get a 7? We know that's going to be a 1 times 7. So I put those there in green. All right, which one would have to be negative in order to have a sum that's negative? Okay, I'm going to add these together. I know the bigger number has to be negative. Okay, so take a look at those green numbers, 1 and negative 7. If you go up, you multiply, you get negative 7. If you go down and add them, you get a negative 6. So that one does work. So my two numbers here that are going to go in my parentheses are a positive 1 and a negative 7. So that one is factored. By the way, we can always go back and check with FOIL. Check to make sure that we did it correctly. So let me get red here. Okay, so remember FOIL is first, outer, inner, last. Okay, so here we go. Let's try this real quick. The first product, x times x, x squared. The outer product, x times negative 7, negative 7x. Inner product, 1 times x, 1x. Last product, 1 times negative 7, negative 7. Okay, and then combining our x terms together gives us the negative 6. And we end up with the original quadratic in descending powers of x. So you can always check with FOIL and make sure it works out. Let's do another one, negative x squared plus 6x plus 16. So it's in descending powers of x, but on this one, notice that my first term, my x squared, is a negative. I want it to be positive, okay? I'm going to write must be positive. So in order to accomplish that, we're going to factor out a negative 1. But if I do that, we have to factor out a negative 1 out of each and every term. Okay, so negative 1 out front and in parentheses now. In essence, that's going to change each and every sign. Okay, so we're going to leave the negative 1 out in the front and we're going to factor the remaining quadratic that's inside the parentheses. So here we go. Let's set up our two parentheses. How do we get x squared? X times x as our first product. We can go ahead and drop down that negative 1 out front. But we're just going to ignore it for now. Next step, we need, look at your constant. Your constant's a negative 16. So you need a product of negative 16 and then your middle term is a negative 6. I need two numbers so that when I multiply them, I get a negative 16, and when I add them, I get a negative 6. Just like before, the only way we can multiply and get a negative product is we have one of each, one positive and one negative. Okay, so let's think of all the ways that we can multiply 16. So we've got 1 times 16. Oops. Okay, I need 1 plus and 1 minus. Is there any way to get a negative 6 out of that? Nope. All right, so let's do the next one. 2 times 8. Does that one work? Yeah, that one does work. 2 and 8. Which one has to be negative if I add these two together? The larger one has to be negative. Okay, so that gives us 2 and negative 8 as the numbers that are going to go in our parentheses. So the 2 is positive, the 8 is negative. Okay, and that one's done. Remember to leave that negative 1 out in the front. Let's do another one, one more. Okay, so this is what it's going to look like to begin with. Obviously, it's not in the right order, so we're going to rewrite it in descending powers of x. So we have the x to the 4th, followed by the x cubed, followed by the x squared term. It's really not factorable yet as a quadratic. In fact, it doesn't even look like a quadratic, does it? Okay, but it's there, it's hiding. We have to factor out a GCF. Okay, greatest common factor. First, look at the x's. Okay, what's the highest power of x that's common to all? So that would be x squared. Okay, now look at the numbers. The biggest number that you can factor out of 3, 21, and 24. It's going to be a 3. However, we're going to factor out a negative 3 in order to make this first term positive. Okay, we want to make it positive. So we're going to factor out a GCF of negative 3x squared. What's left over if we take out a negative 3x squared out of my first term? So that'd be 1x squared. Oh, that's looking good. That's looking like it's going to be a quadratic. Okay, next term. Factor out a negative 3, be a negative 7. Take out an x squared. That leaves us with an x. Okay, so minus 7x. Last term. Factor out a negative 3, and that leaves a negative 8. Factor out an x squared, and then that's just the constant. All right, so we have the remaining quadratic here that we're going to factor. We're basically unfoiling, right? Drop down that GCF, negative 3x squared. That can stay, but we're just going to ignore it for now and focus on the remaining quadratic. Okay, so what do we need? We need a product of negative 8. So two numbers that multiply together to give us a negative 8 and add to get us a negative 7. Okay, so as in the first two examples, what's the only way we can get a negative by multiplication? We're going to have plus and a minus. Right, and as before, we're going to start by saying x as our first term in each parentheses. Okay, ready? Here we go. Two numbers that multiply together to give us a negative 8. So let's see, there's 1 times 8. Does that one work? If one's positive and one's negative, can we get a negative 7 out of that? So that one actually worked. Okay, so first on the first shot, 1 and 8. If we make that 8 be the negative. Okay, so if you multiply them, go up, should be the negative 8. If you add them, you get this number down here, negative 7. Okay, so that works. Those are my numbers that are going in the parentheses. So we have a positive 1 and a negative 8. Factored. All right, let's do some geometry. We have overlapping right triangles. We've already learned about overlapping triangles, and we learned that they are similar. We're going to learn, there's one more thing about overlapping right triangles. Okay, so they have a shared angle. angle there on the left. Remember, it's important to redraw the triangles. Draw the small one, draw the large one. And then you're going to label each side. Looks like, hang on, I need some more room here. Okay. All right, so my small triangle, A, 4, and 5. My large triangle, okay, remember you're going to add the pieces together so that, let me see, a highlighter. Okay, so this little section A, this little section's B, add them together for A plus B. And then at the bottom, I've got a section that's 5 and a section here that's 3. So make sure you add those together. Okay, so here's the deal. We know that they're similar because we see the two angles congruent. AA means AAA. That third angle is congruent as well. So similar triangles. The thing with the right triangle is that one of these triangles, you're going to be able to find a missing side by using Pythagorean theorem. And that would be the small triangle, correct? Okay, so use your Pythagorean theorem. Be careful on this one. You see the 4 and the 5? I know you guys know about the 3, 4, 5 right triangle, but this is not the 3, 4, 5 right triangle. If it were, then the largest number, 5, would have to be the hypotenuse, and it's not. Okay, so over here on the top right, I've already figured this out. This is not a lesson how to do Pythagorean theorem. So you know how to do that already. So you've got A is square root of 41. So A square root of 41. Let's just replace that in green. Okay, so A is square root of 41, which means over here on the right triangle on the right side, this is now root 41 plus B. Okay, cool. So that's going to help us. Let's set up our ratios of our corresponding sides. So my small triangle on the left, I have 4, 5, and root 41. And the corresponding sides for the larger triangle, what goes with the 4? The C. What goes with the 5? It's going to be the 8. What goes with the root 41? It's going to be root 41 plus B. Okay, should be good from there. The unique thing about this is it's got a bunch of square roots in it, so we'll go ahead and solve this one together. Let's solve for C first. That looks easier. So get your 4 over C and the ratio that you know, cross multiply. So 5C equals 4 times 8, 32. Dividing both sides by 5 gives us a C value of 32/5. Okay, so that one's done. All right, let's go find B now. So we're going to use this proportion here. Remember, a proportion is ratio equals ratio, or fraction equals fraction. We have that, we cross multiply. This one's going to be a little bit more complicated, but we can do this. We can do hard things, right? Okay, I like to cross multiply on the diagonal that has the variable in it. So I'm going to do this one first. So here we go, 5 times root 41 plus B, put that in parentheses. So that's a group, equals 8 times root 41. All right, let's distribute 5 root 41 plus 5b equals 8 root 41. Okay, we want to get the b term by itself. So we're going to subtract 5 root 41 from both sides. And remember, 5b equals. I have two root 41s. That's kind of like the same type of term. Okay, just like if the root 41 was an x. If I had 8x minus 5x, it would be what x? 3x. Okay, so 8 root 41 minus 5 root 41 is 3 root 41. Just add or subtract the coefficients out front of 3. Does that make sense? Hopefully you're nodding your head yes. Okay, divide both sides by 5. Divide both sides by 5, and we have b equals 3 root 41 over 5. That does not reduce any further, so that's my answer. All right, so my solution's done. Here it is beautifully here. What A is, what B is, and what C is. Okay, so that's overlapping right triangles. You're going to use Pythagorean theorem. Pythagorean theorem to find one of the missing sides, and then you're going to use similar triangles to find the rest of the variables. And we are done.